This is an AS Further Mechanics 2 question on acceleration varying with velocity. A particle P moves on the x-axis. At time t seconds, t greater than or equal to 0, the velocity of P is v meters per second in the direction of x increasing, and the acceleration of P is a meters per second in the direction of x increasing. When t equals 0, the particle is at rest at the origin. Given that a is equal to 5 over 2 times by 5 minus v, part A, show that v is equal to 5 times by 1 minus e to the power negative 2.5 t. Right, first thing to note is my initial conditions over here. So I have when t is 0, it's at rest, so v is 0, and it's at the origin, so x is 0. So for part A, what we want to do is note that a is equal to dv dt, and we're going to take a and replace it with dv dt. So we have dv dt is equal to 5 over 2 5 minus v. We're going to separate the variables, so then we will have 1 over 5 minus v dv is equal to 5 over 2 dt. We're going to integrate both sides. Now, to make this so that we can just do the log of the bottom, I know that if I differentiate the bottom, I'm going to get -1, so I'll put a negative there, and we need to put a negative there to keep it balanced. So what we have now is negative log 5 minus v is equal to 5 over 2 t plus c. Right, I need to make v the subject, which means getting rid of log. So what I'm going to do is I'm going to bring this negative as a power, so it's basically 5 minus v to the power -1, which is going to be the same as doing the log of 1 over 5 minus v, and that's going to be equal to 5 over 2t plus c. Now what I'm going to do at this point, I could do it later, is I'm going to find out the value of my constant c by substituting that into here. So v is going to become 0, t is going to become 0. So on the left, I'm just left with log of 1/5 is equal to c. So there's my value of c. So I can now write down my particular solution, which is going to be log 1 over 5 minus v is equal to 5 over 2t plus log 1/5. Now what I need to do from here, I'm going to raise both sides to power e, which means that the e and that log cancel out because I now want to make v the subject. So I'll have 1 over 5 minus v is equal to e to the power 5 over 2t times by e to the log 1/5. Now the e and the log there will cancel out. So now I'm up to 1 over 5 minus v is equal to 1/5 e to the 5 over 2t. Now I need to do the reciprocal of both sides to get that v. So I will have 5 minus v is equal to, so the reciprocal of a fifth is 5, then the reciprocal of that power is going to be a negative power, and then we're almost there. Make v the subject, so v is going to be equal to 5 minus 5e to the negative 5 over 2t. Now we want to leave it exactly the form that they have, so they factor out the 5 and they've written negative 5 over 2 as negative 2.5. So we're going to do exactly that, and then we can put as required at the end. Okay, part B, state the limiting value of v as t increases. Okay, so as t increases, so let's say t is approaching infinity, what's that limit? Well, the bit that's got the t in it is this part here. So as t increases, we're going to be doing e to an increasing negative power, which means that is actually going to be getting smaller. That's going to be approaching 0, which means all that's left is going to be 5. So we just need to state the limiting value without any explanation. So I'm just going to put down 5. Okay, at the instant when v is 2.5, the particle is d meters from O. Part C, show that d is equal to 2 log 2 minus 1. Right. So finding the distance, that's displacement. So I need to take my velocity and realize that v is equal to dx dt. Replace the v in the equation for part A, and then write dx dt is equal to 5 times by 1 minus e to the minus 2.5t. Separate the variables. So I'm going to pull the 5 over. I don't need to, I can keep it as, but I'm going to write 1/5 dx is equal to 1 minus e to the negative 2.5t dt. I'm going to integrate both sides. So on the left, I'm going to have 1/5 x. And then on the right hand side, I will have t. And then minus. Now using a reverse chain rule, I'm going to be dividing by the inside differentiated, which is going to be dividing by negative 2.5. Integrate the outside so it stays as e, and then remember that the brackets, inside of the brackets, or the inside doesn't change. Now I'm not going to need any constant of integration here because I'm finding a distance, and hopefully you'll remember that to find a distance we need to integrate between limits. So because we're using limits, there is no plus c, and it's going to be v dt. Now we've already done the integration, we just need to put limits in, because integrating v is the same as integrating dx dt, which we've done. We just need to tidy this up into a form where we can put the limits in. So I'm going to start by timesing both sides by 5 and tidy up this sort of fraction I've got here. So I'll have x is going to be equal to 5t plus 2e to the negative 2.5t. So it's this we need to put the limits in. We're now going to work out what the limits are. So 5t plus 2e minus 2.5t. And we want to find the distance from O. Now we know that when it was O, that was at time equals 0. So we know that this limit is 0. We need to find this upper limit here, and this upper limit, this time, is going to be when v is 2.5. So using v is 2.5, we want to find t. So the 2.5 is going to go in here to allow us to find what t is. So let's just do that working. So we're going to have 2.5 is equal to 5, 1 minus e to the minus 2.5t. I guess from there, what I'll do is I'll divide both sides by 5. So 2.5 divided by 5, that's going to be a half, is equal to 1 minus e to the negative 2.5t. So e to the negative 2.5t is going to be equal to a half. So we want to do the log of both sides of that. So that will mean that I have negative 2.5t is equal to the log of a half, or 0.5. So now I'll divide both sides by negative 2.5. So that will give me 2/5, or negative 2/5, or t, rather, don't want to forget about t. T is equal to negative 2/5 log a half, and we can tidy it up, make it a little bit nicer as a limit. So t is going to be equal to 2/5 and then log of a half to the power minus 1, which will be 2. Okay, so log 2. So here's my upper limit, which I'll put up here as 2/5 log 2. So now just the substitution. So 5 times by 2/5 log 2 plus 2 times by e to the negative 2.5 times by 2/5 log 2 minus 5 times by 0 plus 2e to the negative 0.25 times by 0. So first of all, the 5's here will cancel out, just leaving 2 log 2. Now, I didn't worry about simplifying this, I just simply typed it on my calculator, and all of this just works out to be 1. Then we're going to subtract, so this is just 0. Now anything to the power 0 is 1, so you've got 2 that we're subtracting. So that simplifies to 2 log 2 minus 1, which is what they want. So we'll just put as required.